Now we have the Geometry and Data Interim 3 Study Guide, page 2. Problem number 7 begins line segment KM is the altitude drawn to hypotenuse JL in right triangle JKL. So I'm going to draw a sketch of that. So it looks like JKL and KM is an altitude drawn from vertex K. If JL is 17, so if this entire length is 17 and KL is 15, then find ML to the nearest tenth. So I'm looking for the length of ML. So basically, when you have a right triangle with an altitude from the right angle, it creates three similar triangles. I have the big triangle JKL, which I'm going to highlight in blue. So JKL is the full triangle. And then I have two smaller triangles. I have triangle JMK and KML. I'm going to highlight triangle KML in green. So you can see I have three different similar triangles. And if I look in regards to the blue big triangle, I'm given the hypotenuse and the long leg. So if I look at the big triangle, if I'm going to do the hypotenuse to the long leg for the big triangle, the hypotenuse is 17 and the long leg is 15. Now, because I know these triangles are similar, I can set up a proportion. So I'm going to set it equal to the green triangle. The green triangle's hypotenuse is 15, and the long leg is x, which is what I'm looking for. Now I can use cross products to solve for my missing side length, which was the long leg of the green triangle. So 15 times 15 is 225 equals 17 times x equals 17x. If I divide both sides by 17, I find out that x equals 13.235, and it says to round to the nearest tenth, so it would be 13.2 units. I'm not sure what the units are. Okay. Number 8, they want me to find the angle of elevation of the plane. So I'm looking for angle A, and I'm given the opposite and the adjacent. So I want to think back to my SOHCAHTOA and realize that opposite and adjacent would be tangent. So I'm going to set an equation up. The tangent of angle X is equal to the opposite over the adjacent, okay, which is 300 over 400. Now I can solve with inverse tan is 300 over, over 400, which is 3/4. So if you wanted to reduce that down, that would be easier, or put it as 0.75, whatever is easier. But I'm going to just leave it like is. So I hit second tan, inverse tangent. 300 divided by 400 is 38.9 degrees. Okay. Number 9. Says in right triangle DEF. I'm going to draw a sketch since they didn't give one to me. DEF. Angle D is 54 degrees. E is the 90 degrees. And DF is 8.5. That's my hypotenuse. What are the lengths of DE? I'm going to call that X. And EF, I'm going to call that one Y to the nearest tenth of a centimeter. Well, this is really two problems built into one. So first, to solve for X, to find DE, I'm going to look at, I have given an angle. I'm looking for the adjacent, and I have the hypotenuse. So I'm going to need to use cosine. So cosine 54 equals my adjacent over my hypotenuse. To solve this equation, you just multiply both sides by 8.5. And if I put that in my calculator, I have 8.5 cosine 54. And I find that that side length DE is 4.996. To the round to the nearest tenth would be 5.0 centimeters. Okay, so that's to solve for DE. Now I need to solve for EF. For EF, I called that side Y for my equation. In reference to angle 54, that is the opposite, and I have the hypotenuse. So I'm going to use sine 54 equals the opposite over the hypotenuse. So again, I'm going to multiply both sides by 8.5. And in my calculator, I'm just going to type in 8.5 sine 54, and I find that that would be 6.9 centimeters. So EF is 6.9 centimeters. Number 10, Mrs. Lassard walks north 100 yards. Okay, and then she turns and goes 60 yards west to get to the opposite corner of the field where she started. How long, what's the shortest distance for her to walk back? The shortest distance between 2 points is a straight line, which is the hypotenuse of this triangle. So I'm going to look at, I have two sides in a right triangle, and I'm looking for the third, so I can use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. I'll call that my x. Okay, so 60 squared is 3,600, and 100 squared is 10,000. When I add those together, I get 13,600 equals x squared. Now to undo a square and finish solving this equation, I have to use the inverse and take the square root of both sides of the equation. The square undoes the square root, out pops the x, and the square root of 13,600 is approximately equal to 116.6 yards. All right, problem number 11. Triangle ABC shown below is a right triangle. AC is 26, so I'm going to start marking that up right away. Centimeters. AB is 24, and BC is 10. Find the following. The sine of A. Well, I'm going to write SOHCAHTOA up top here. The sine is opposite over hypotenuse, so the sine of A is 10 over 26. Because the opposite to angle A is 10, and the hypotenuse always stays the same. It should always be opposite that right angle. Cosine B. Cosine is adjacent over hypotenuse, so this would be 24 over 26. Now these can all be reduced down or put in decimal form if you wanted to. That would be fine. Sine B would be, oh, I can't find sine B. That can't be done. That's a right angle. We can only find the sine, cosine, and tangent of the acute angles in a right triangle. Cosine A would be adjacent over hypotenuse, which is 24 over 26. You know, now that I'm looking at this, I think this meant to be cosine C, and that's what I did when I did the problem. That's a mistake, guys, on the answer key. I mean, on the study guide. That should have been sine C. And sine C is opposite over hypotenuse, which is 24 over 26, which reduces down to 12 over 13 if you wanted to do that as well. Okay, and then cosine A is, I'm getting all mixed up, I apologize. Cosine A is adjacent over hypotenuse, which is 24 over 26. Tangent A, tangent is opposite over adjacent, so it would be 10 over 24. Or if you wanted to reduce it down, it would be 5/12. Tangent, yeah, I made a mess on this problem, I apologize. This should have been tangent C. Tangent C would be 24 over 10, which is the reciprocal. So the complementary angles are, the tangents will be reciprocals of each other, which is 12/5. So I'm sorry about that, I messed that up. This should have been cosine C. Cosine C should have been 10 over 26. Sorry about that, guys. Which of course is 5/13. Okay, and what you'll notice is that the sine of one angle is equal to the cosine of its complement, or essentially the cosine of the other acute angle in the triangle. Same here, the sine of C is equal to the cosine of A. And then the tangents end up just being reciprocals of each other. All right, last two. A right triangle has legs, each the length of 2 square root 2. What is the measure of the two non-right angles? What is the length of the hypotenuse? Well, they're telling me that the right triangle each has legs of 2 square root 2, which tells me that this is an isosceles right triangle, which means that the base angles both need to be 45 degrees. So this is a special right triangle called a 45, 45, 90. And there's a special relationship in a 45, 45, 90 triangle that says the sides, the two legs, are congruent to each other, and the hypotenuse is the leg times the square root of 2. So if I wanted to find the hypotenuse in my original triangle, I would have to take the leg times the square root of 2. So 2 square root 2 is the leg times the square root of 2 to get to the hypotenuse. Square root of 2 times square root of 2 is 2. Some people like to think of that as the square root of 4. So 2 times the square root of 4 is really 2 times 2, which is 4. So the hypotenuse in that triangle would be 4, and the missing angles would be both 45 degrees. And the last problem, number 13, Mr. Healy drew an equilateral triangle and added an altitude from one vertex to the opposite side, creating two congruent smaller triangles. So he drew an equilateral triangle. If the side lengths of the original triangle are 10 inches, so each side is 10, and if I drew an altitude down, okay, I know that in an equilateral triangle, all three angles are 60 degrees. So each of these angles are 60. And that when you drop the altitude, it actually creates a 30, 60, 90 triangle, two different congruent triangles, where the long leg, the hypotenuse is double the short leg. So if we look at a relationship of a 30, 60, 90 triangle, we have the short leg, if we think of that as x, we multiply it by 2 to get to the hypotenuse, and we multiply the short leg by the square root of 3 to get to the long leg. So here I have to work backwards. So to go from the short leg, which is opposite the 30-degree angle, I would have to multiply by the square root of 2. Take that back. Multiply by 2. To go backwards, I would have to divide by 2. So the short leg would be 5. To go from the short leg to the long leg, I have to multiply by the square root of 3. So the altitude of this triangle is 5 square root 3. So the altitude is 5 square root 3 inches. And the area of the triangle, the altitude is the height. So area is base times height. We know that the base of the full triangle, all the sides to begin with, were 10 centimeters. So the area would be 10 times the altitude, which is our height, 5 square root 3. So our area would be 50 square root 3 inches. or